Here we're going to take a look at rational functions in the graphs and the equations of those. In the top left corner, we see the parent function, which is the most basic rational function, y equals 1 over x. Notice from the graph that there are asymptotes, which are those invisible borders that the graph does not cross. So there's a horizontal asymptote at y equals 0 and a vertical asymptote here at x equals 0. So as we change that equation, y equals 1 over x, this graph is going to shift up and down, right and left, or enlarge or compress. So we're going to look at some examples of that happening and how that equation changes. So if we look at this graph in the bottom right, let's look at how this has moved. I like to focus in on where the asymptotes are now. So here we see the horizontal asymptote is still there at 0, but the vertical asymptote now is at x equals 3. It was at x equals 0, now it's at x equals 3. So this moved to the right 3 units, or it's a horizontal translation of 3. So how does that change our equation? It was y equals 1 over x, but now we are going to subtract 3 from x within that equation. So before we do the division, we are going to subtract 3 from x. So this is the equation of this graph. Let's look at another one. So again, let's look at where the asymptotes are. The horizontal asymptote is no longer at 0, it's now at 2. So it shifted up 2 units. The vertical asymptote, though, is still here at 0. So this one shifted up 2 units. It's a vertical translation 2 units up. So what we're going to do is we are going to add 2 to that function. So if our parent function is this, we are going to add 2 after that function. Let's look at another one. This one has more than one thing going on, and the asymptotes are already sketched in there for us. So we see there's a horizontal asymptote at 1. So it shifted up 1 unit. And there's a vertical asymptote at 2. So it shifted to the right 2 units. So it went up 1 unit and to the right 2 units. So how does that change our equation? Our parent function is y equals 1 over x. So moving it to the right 2 is going to subtract 2 from x. Before we do the division, we have to subtract 2 from x. And then we are going to go up 1, so we are going to add 1 after that function. Now, the last thing I want to look at are a couple of examples of compression and stretching or enlarging. This is called dilating. So dilating is when you multiply a parent function by some number. So in this case, what we did is we multiplied, skipped one. We multiplied by 3. So if you look at this, we took 3 and we multiplied it by 1 over x, and that gave us this. So how did that change? Notice that our asymptotes are still in the same place, but our graph got further away from those asymptotes. It stretched, it enlarged by a scale factor of 3. That's how you would describe this. If instead we multiply by a number that is between 0 and 1, like a fraction, so in this case, I'm multiplying by 1/3. And we get this. So what happens to the graph here? So again, our asymptotes are in the same place, but notice that it gets a little bit closer. The graph gets a little bit closer to those asymptotes. That's called compression. So this was compressed by a scale factor of 1/3.